Hi guys, this is Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video is going to deal with the calculation of type 6 probabilities, and we've defined type 6 probabilities to be probabilities of z-scores lying between two negative values, let's say x1 and x2, where x1 is a negative value and x2 is also a negative value. Okay? So let's just have a look at this type of probability that we're interested in. So we're interested in the probability of observing a z-score between two negative values. So the z-score is with respect to the standard normal curve. So when we draw the standard normal curve, we know it's centered on 0. The horizontal axis represents our z-axis. And we have two negative values. x1, let's say, is out here. And let's say x2 is here. And we're interested in the probability of observing a z-score between those two values. So this particular probability calculation is effectively, can we calculate the area between these two negative values here? Okay, so let's have a look at a particular example. So I'm interested in calculating the probability of observing a z-score that's greater than, let's say, minus 2.37, and that's less than, let's say, minus 1.46. Okay, so the first thing that we'll always do when we're calculating these probabilities is we always draw the standard normal distribution, or the standard normal curve. So when we draw the standard normal curve, it's centered on 0. The horizontal axis is our z variable, or our z-axis. Minus 2.37 is going to be out here somewhere. Let's say that's minus 2.37. And minus 1.46 is closer to 0, so minus 1.46 is around here. And we're interested in the z-score being between those two values, so we're ultimately being asked, can we calculate the area between those two negative values here? Okay. Now what we know is that when we calculate negative values, that we cannot look negative values up on our tables, because our tables only have positive z values. But like our previous examples when we're dealing with negative values, we know the properties of the standard normal distribution. And that one of the properties of the standard normal distribution is that it's symmetrical around 0. So what we could do in this situation is we could rotate the curve. So if we rotate the curve through 0, this particular curve, when we flip it over, it's still a standard normal curve that's centered on 0. The horizontal axis is still the z-axis, but minus 1.46 when we rotate it over becomes a distance of 1.46 from 0 over here, so that's 1.46, and minus 2.37 when we rotate it over becomes a distance of 2.37 from 0. We're interested in the probability of a z-score being between those two values. So in this situation, through the rotation, we're interested in, can we calculate the area between those two values there? So this probability here now that we've just calculated, this is equivalent to that particular probability with respect to the negative values. And this probability here is the probability of observing a z-score that's greater than 1.46 and less than 2.37. Okay, so let's work with this probability. And this is very similar to our type 3 probabilities. It's the same, except that our bounds have changed, where we have two positive values. So what we know is anytime we have positive values, what we should always immediately do is we should always look those positive values up on our tables. Okay, so when we look up 1.46, we're going to come down to 1.40, and we're going to come across to 0.06, and we're going to triangulate in to get the area to the left hand side of 1.46. Now when we look up 1.46 on our tables, we come down to 1.4 and we come across to the column labeled 6. So that particular value here is 1.46, which is 0.9279. So that's 0.9279. Okay, so that's the area to the left-hand side of 1.46. Now when we look up 2.37 on our tables, we're going to come down to 2.30, and we're going to come across to 0.07, and we're going to triangulate in to give us the area to the left hand side of 2.37, okay, which when we look up 2.37, so we're going to come down to 2.3, and we're going to come across to the column labeled 0.07, so we're coming down to 2.3 and 0.07, which gives us a value of 0.9911. So this is 0.9911. In other words, when we look up 1.46 on our tables, it gives us the area to the left hand side of it, which is 0.9279. And when we look up 2.37, it gives us the area to the left hand side of that, which is 0.9911. And like our type 3 probabilities earlier on with two positive bounds, we know that if we take the shorter line away from the longer line, what we're left with is the area between those two values. In other words, we have the longer line, which is 0.9911, and we're going to take away the distance or the length of the shorter line, which is 0.9279. When we do that on our calculator, we have, okay, so we have 0.9911 minus 0.9279 to give us a value of 0.0632. In other words, the area between 1.46 and 2.37 is 0.0632. which is exactly the same through rotation as the area between minus 2.37 and minus 1.46. In other words, the probability of observing a z-score that's greater than minus 2.37 and less than minus 1.46 is equivalent to the probability of observing a z-score that's greater than 1.46 and less than 2.37, which is equal to 0.0632. Yeah? Or equivalently, it is 6.32%. In other words, you should see a z-score between minus 2.37 and minus 1.46 about 6.32% of the time. Okay guys, thank you very much for your time, and that concludes this short video on how to calculate type 6 probabilities. They're probabilities where we're interested in a z-score being bounded between two values and those values being negative. And the most important thing with respect to this particular scenario is that we can never look up negative values on our tables, but we can always look up positive values, and through one of the characteristics of the curve being symmetrical, we can always rotate our two negative values to be positive values, and that this area between these two positive values is equivalent to the area that we were looking for between the two negative values. Okay guys, thanks for your time. I am Jonathan Lambert at the Mathematics and Development and Support Service at the National College of Ireland.